Hello, welcome to the second day of 7.3. Today we're going to be looking at tangent and chord properties in relation to circles. By the end of the day, you should say I can use tangent and chord properties to discover new information about my circle. The first property that we need to talk about is that a tangent from outside of a circle is always going to form 90 degrees or be perpendicular to the radius drawn on the point of tangency. Hopefully everybody knows that perpendicular lines cross at 90 degrees, like this. Now our next property that we're going to need to know is tangent segments to a circle from a point outside the circle are congruent. Now this is a good drawing, but maybe it would make more sense if I drew and started from scratch. So if I have a circle and I have a point out here, if I draw a tangent line here and draw a tangent line here, the distance between the point of tangency and our point out here is going to be the same distance. So if this is 8, this one down here has to be 8. And what's important about this is if we go to the center here and center here, these are both radii, so those have to be the same. So say this is 3 and 3, so this makes a kite. So whenever you have a tangent segments from an outside point, it automatically makes a kite. Oop. The next page, a perpendicular from the center of a circle to a chord is a perpendicular bisector of that chord. So if I have some chord out here and I have my center point, the perpendicular line, if I just go and I hit this perpendicular, like so, I know that this side has to be congruent to that side. So whenever we have a chord, if I want to find out how to cut it in half, all I have to do is draw a 90-degree intersection from the center to that chord, and I know I cut it right in half. Similarly, I don't having trouble with that word, but the perpendicular bisector of a chord has to pass through the center. So if I have a chord just sitting out here, and I do a perpendicular bisector of it, like so, that means it cuts it in half and it's perpendicular. That has to pass through the center of our circle. All right. So here's a few problems. If CA is 20, this whole chord is 20 centimeters long, what's the length of AM? Well, we learned that the perpendicular to the chord is going to cut it in half. So each side here is going to be 10. So AM has to be 10 centimeters. All right. Now this one uses a couple properties. First, we talked about this forming a kite. So, and also coming from a radius, that makes a 90 degrees with a tangent. So that's 90 degrees, and that's 90 degrees. So right off the bat, we can take, we know that this is 90 and that's 90, so these two add up to 180 degrees. So 180 degrees plus 40 plus x has to equal 360. So if I take 360 minus 180, I know that's 180 degrees. So this angle and this angle has to add up to 180 degrees. So 180 minus 40 will give us what x is, which is 140 degrees. So whenever you see a setup like this, and you know these two have to be 90, you can just take 180 minus this value to get that one, or 180 minus this to get that, because these two would have to be supplementary. All right, now this one is actually not written well in our notes, so we can skip this one for today. And this next one, it says M is the midpoint of AB. The radius of the circle is 20, and AB is 16. Find the length of CM. Now this one is kind of tricky. we want to find this. We know this whole distance, AB, is 16. So hopefully we know that this is 8. Since the radius of the circle is 20, this distance here is a radius, so that's going to be 20. So we can use Pythagorean theorem to find this because this is a right triangle. Let's call this A. And we know in a triangle A squared plus B squared, which is now 8 squared, is equal to 20 squared. So A squared plus 64 is going to be 400. Now we subtract 64 from both sides, and 336 is going to be A squared. So now I take the square root of both sides. The square root of 336 is 18.3. So 18.3 is going to be this whole distance. Now we know the whole distance from O to C, since that's a radius, is going to be 20. So 20 minus 18.3 is going to be 1.7. So cm is equal to 1.7 centimeters. All right, now we're done with the lesson. So I want you to be able to say how comfortable you are with today's lesson. We were using tangent and chord properties to find out new information about our circles. So now you can work on classwork and finally the homework. Good luck.